Hey everyone, welcome back. Today, I'm going to show you how you can build an AI-powered interviewer that can conduct real job interviews. So this isn't just a chatbot, it'll speak naturally with text-to-speech, understand our answers with speech recognition, and ask structured interview questions while automatically saving our responses. It can even answer company-specific questions using RAG, making the whole experience feel real and interactive. In this tutorial, we'll set up LiveKit as the real-time voice AI framework, build a LangGraph workflow to manage the interview flow, and we'll also add a visual avatar and set up recordings so all of our responses are saved for later review. By the end, you'll have a fully working AI interviewer that can screen candidates 24/7, perfect for HR teams, recruiters, or anyone who wants to automate the first round of interviews. When it's all set up, it should look a little something like this.
Thank you for joining us today. Let's start with the basics. Could you tell me about yourself? Please share your background, what you're passionate about, and what brings you here today.
Yeah, so my name is James. I have a background in software engineering and I have interest in cloud computing and building AI solutions. And honestly, what had me interested was the salary.
That's great to hear, James. Now, I'd love to learn about your technical background. Could you tell me about your experience with technology? What technologies, programming languages, or technical projects have you worked with?
Yeah, one that comes to mind is a sales CRM that I built using Django. I wrote it in Python, and I also used PostgreSQL on the background, in the back end to store some information about the users. So yeah.
Excellent. Now, I'd like to hear about a time when you faced a significant challenge, either technical or professional. Could you walk me through the situation, what obstacles you encountered, and how you overcame them? What did you learn from that experience?
Yeah, one time when I was coding in my previous internship and I made a pull request, I forgot to check for the continuous integration checks, so I did not validate my code and it didn't agree with what we had deployed. So I had to fix that by meeting with the lead engineer, but after that, I did not make the same mistake twice.
Thank you for sharing that with me, James. Now I'd like to give you the opportunity to ask me anything about our company, the role, or anything else you'd like to know. What questions do you have for me?
Yeah, can you tell me about your guys' mission statement?
Our mission at Tech Company Inc. is to empower businesses through intelligent automation and data-driven decision-making. We envision a world where every organization can seamlessly integrate AI into their operations to improve efficiency and unlock growth. If you have any more questions or need further clarification, feel free to ask.
Yeah, can you tell me about some of your guys' key clients?
Our key clients include some Fortune 500 companies across various industries such as finance, healthcare, retail, and manufacturing. Notable partners include Megabank, Health Plus, Retail Mart, and Automotive X. If you have any more questions or need further details, feel free to ask.
Got it. I think that's it for now, and I'm looking forward to hear back from you guys.
Thank you, James. It was great speaking with you today. We'll be in touch soon regarding the next steps. Have a wonderful day.
Like always, head over to your IDE and open up a new project. So I'm going to click here on Open Project, and I'm going to click on New Folder. And I'll just call this LiveKit LangGraph Project. And I'll click Create, and I'll open. All right, cool. So we're in Cursor, and our project is created. We have to open up our terminal, and the first thing we want to do is authenticate to LiveKit. So in order to do that, run the command lk-cloud auth. And when you click enter, you'll see it'll ask you for the name of your device. And when you click enter again, it'll take you to the browser. So go ahead and click enter and then go to the browser tab that is opened. The tab popped up in the browser and it should for you as well. So you can just click a project to authenticate to. I'm going to click on LK Cloud Project and allow access. Now access is granted. We can just close out this tab and head back to our IDE. All right, so now that we are authenticated, we have to set up our actual repository with our files. And for that, we actually don't have to run git clone anymore. So the command we run to do that is uv init livekit voice agent hyphen bear. So type it in exactly like this. You can also see on the docs yourself, but just click enter. And then we have to cd into this new livekit voice agent folder. So I'm going to do that by cd livekit and just press tab, enter. And now if we take a look, we're just going to have this one file right here, which is going to include our dependencies, which will be our next step. So let's do that right now. All right, so the next command we have to run is this one right here, where we run uv add and install all of these following packages. It says install the following packages to build a complete voice AI agent with our whole pipeline. So I'm going to go ahead and copy this, but it is a pretty long command. So I linked these Voice AI quick start docs in the description. So you can just grab them from there, go to the link, scroll all the way down past where we already did this, and go to the install packages, copy this, and head back to your code. Now I'm going to paste that in and click enter. And as you can see, we just installed all these packages, including a lot of packages for our pipeline. So DeepGrams is what we're going to be using for speech to text. Our OpenAI will actually generate our response for us, and Cartesia will give a voice to our agent. The next step is we have to set up our environmental variables, but since we are just authenticated to LiveKit, we could do something pretty cool. We could just run this command, lkapp-env-w, and what that'll do for us is it will load our LiveKit secret keys into our .env file. So if I click enter right here, you can see here that we just made this .env.local file, and we already have all of our LiveKit information. We just have to input a few more keys like our OpenAI, DeepGram, and Cartesia keys to have our voice agent functioning. And as you can see from the docs, we have to add these 3 API keys. So I'm going to just copy that and paste that in my code and fill in as we go. All right, so I'll paste this in. All right, and so I just pasted in my API keys. I have included links to get your OpenAI, Cartesia, and DeepGram API keys in the description. It's a pretty straightforward process. Now we need our code to actually set up our voice agent. So in the docs, if you scroll down to agent code, it'll provide all of this for us. This is how we get our agent functioning. We're loading all of our imports, setting up the agent class, and configuring and starting the session. So just copy this file right here. LiveKit gives us all the code, and head back to your IDE. All right, so back in the code, let's add a new file, call it agent.py, and paste in that file that we just copied. You can see it's not too long, it's about 46 lines, so it's pretty straightforward. All that we're doing here is importing our plugins, loading our environmental variables from that .env.local file that we just created. We are creating a class for our assistant, and the reason we do that is to initialize it with some instructions. So we were saying you are a helpful voice AI assistant, very basic. And then we have this asynchronous entry point function, and what that does is it sets up the session, which is our pipeline, right? We go from speech to text, so we speak to it. What we say gets transcribed into text, which gets plugged into an LLM. And then once we get our response from that LLM, we are going to feed it into a text-to-speech model so that our agent will be able to speak that response out to us audibly. And then these 2 last imports down here are for noise cancellation, turn detecting. We actually start the session. We initialize our agent with this assistant class that we made up above. And then we also have this generate reply function. And then LiveKit kicks off the whole thing with this run app function. Okay, so make sure you have this saved. And in the docs, it says to use the turn detector, Celero, and noise cancellation plugins, we first need to download the model files. So that looks like the last command we have to run. Let's copy that and head back to our... Looks like I made a mistake. I actually put our agent.py in the parent directory instead of in this LiveKit voice agent folders. So I'm just going to move that over here. Okay, now we're going to run that command that we just copied, uv run agent.py download files. And let that run. All right, now it's time to actually run our agent. So we did everything we needed to. We pasted the agent.py code. We set up our environmental variables, installed dependencies, and downloaded the different files for the plugins. So let's clear this terminal right now. The command we need to run to speak with our agent in the terminal is uv run agent.py console. Now, when you click enter here, the agent is going to be summoned to the terminal and we'll be able to speak with it. All right, so I'm going to click enter, wait for the agent to show up.
Hello, I'm here to help you. What can I assist you with today?
Yeah, can you just tell me a fun fact about San Francisco?
Sure. One fun fact about San Francisco is that it is home to the famous Painted Ladies, a row of Victorian and Edwardian houses that are known for their colorful exteriors.
Awesome. And can you tell me a fun fact about New York?
Absolutely. One fun fact about New York City is that it has its own Lady Liberty statue. But did you know that the original Statue of Liberty was a gift from France?
And to quit, just press Control C. All right, so we see that our voice agent is fully set up. Now we can start building out the actual interview functionality with LangGraph, and I'll show you exactly how to do that. All right, so this is the graph that we're going to be building to set up the interview functionality with LangGraph. And by the way, I was able to learn this, and I got most of my LangGraph code from a free LangGraph tutorial from freecodecamp.org, which I linked in the description. It's a 3-hour tutorial which goes over everything in LangGraph. Super helpful, so if you want to learn LangGraph, just check it out there. So now let me just break this down. Usually when we set up these voice agents, our speech just gets fed right into the LLM. Let's say if we were to ask it, hey, can you tell me a fun fact about San Francisco? Our speech would get transcribed to text, and then that would be plugged into the LLM, and the LLM would generate us an answer. But what we're doing differently here is our speech is going to be going down this graph, right? So we're going to be speaking to our agent. It's going to take what we have just said, and we're going to be starting here at this beginning node. Then we're going to hit the LLM node, and it's going to decide, do I need to call a tool right now? And we're going to have two tools. One of the tools is going to be to record our answer, so recording what we said and jotting that down in a text file. And the second tool is going to be for our local RAG. So if our interview says, hey, do you have any questions for me? And I were to ask, hey, yeah, can you tell me a little bit about the company's culture? The LLM doesn't know that off the bat. So it's going to have to perform a tool call to retrieve this data using RAG. And instead of going right to the end and answering the question, it will hit this tool executor node. So when we say something, it goes to the start node, it hits the LLM node, decides whether we need to call a tool, or if we don't need to call a tool, we're asking it a basic question saying, hey, what's the company name? A response made by the LLM would go straight to this end node and then spoken back to us. But this way we can set up this graph so we know that we are hitting the LLM saying, okay, do I need to answer a question right now? Do I need to record an answer? Do I need to call a tool? Or can I just generate an answer and then feed that back to the user? That's the cool part about LangGraph. You can control the conditional branching flow when we ask our LLM questions instead of just invoking it immediately. All right, so to get the code, we're just going to be copying my graph.py file that I have in my GitHub repository. I put the link in the description for my repository, but when you're here, just copy this whole file and head back to your code. All right, so now we're just going to install LangGraph libraries and dependencies. So go ahead and paste this command in. We're going to be using UV and click enter. Now let's create that new graph.py file that we just copied. So I'm just going to paste this in right here. Now that we have our imports, I'm going to be explaining this graph.py file. So the job of this file is to build the LangGraph brain that powers our interview agent. By the end, it returns a compiled graph that my LiveKit voice agent can call into. So first things first, the imports. It's a bit easier to explain the imports as we go, but just from face value, we're loading in our environmental variables, like what we set in .env.local. And we're importing the operating system, so we have access to write in a file. Like I mentioned before, the way that we're going to be recording our responses is by writing this into an actual text file. So we need the operating system. And then from typing, we import these typedict annotated in sequence. These help define the shape of the graph state. The state is basically a set of data that is being passed through the graph and partially modified as it moves around nodes. And then this add messages operator right here tells LangGraph how to accumulate messages across turns. Next are the LangGraph and LangChain pieces. So stateGraph and end gives me the graph object and a special end marker when we know to actually return our response and have the agent speak that out. And then these different types of messages are just basically chat bubbles, which the LLM understands. And then from OpenAI, we need chat OpenAI. That's what we're going to be using for our LLM in the node. And then we need OpenAI embeddings. And embeddings just takes our data and puts it into vectorized format, meaning we're going to have this PDF of company information, and all the information in it is going to be embedded as some form of numerical value. This helps when we're doing RAG because when our agent takes our question, it queries the database for information that is numerically close to what we are asking to return to us a response. This is just basic RAG. Then we're going to be using PyPDF loader to work with and chunk down our PDF, Chroma for the database, and tools so our agent will have the ability to call tools asynchronously in real time. All right, so this whole file is basically just one big function. And there's a reason I did that. Over here in the LiveKit docs, if we just go to integration guides, then large language models, and then LangChain, we can see here we have this LangChain integration guide. And it says how to use LangGraph workflows with LiveKit agents. LangChain is a framework for developing applications powered by large language models. The LiveKit LangChain plugin allows you to integrate existing LangGraph workflows as LLMs in your voice applications. So we're basically substituting the LLM like we had earlier in our agent.py file for this new LangGraph workflow that we have in our graph.py file. So we have to make sure to install the plugins. And then we see here, what it says to do is make this create workflow function where we define all of our nodes and then compile that, and then actually use this LLM adapter function to set the LLM instead of just passing in our OpenAI LLM. And it says to make this create workflow function. This is where we actually configure our nodes, configure what our workflow will be doing and how our graph will be structured. We compile it and return that. And then when we're declaring our session, like we did previously in our agent.py file, we just have to switch out the LLM declaration. So we previously had it as chat OpenAI, but now we're just going to use this LLM adapter method and pass in this create workflow function, which is exactly what we're going to be doing in the code. So let's install this command just to be sure. So copy this and then head back to our code. All right, so let's paste that in. And remember, we're using UV instead of pip install. So I'm just going to delete this right here, UV add, and then press enter. Okay, now I'm going to go over the code. All right, so like I mentioned, and as we saw in the LiveKit docs, the real work happens inside this create workflow function. So first we set up the model in the embeddings. That gives me an LLM for conversation and an embeddings model to turn text chunks into vectors for search. Next, I point to a PDF that has company info. What I did is I went to ChatGPT and I said, hey, can you make me a PDF about a fake tech company's info? So we got different information, as you can see here, about us, mission, financial highlights, and this is what we'll be using to actually retrieve the data using RAG. And there's some pretty specific statistics. So we'll ask it, hey, what has your guys' revenue been? And it should be able to tell us 8.4 billion. So head over to ChatGPT or any PDF that you'd like to use for this and set the PDF path to where you have that on your computer. So I put it in my downloads as 10companyinfo.pdf. So once we have that PDF path, we check if it exists. And if not, we just raise a quick error. Otherwise, we're going to use this PyPDF loader that we imported and pass in our PDF path. And this .load method allows us to store our PDF in this pages variable. Then, as you may know, if you're familiar with RAG, the first step is chunking our information. So right here, we're using the recursive character text splitter. We were just using the basic chunk size for 1,000 and a chunk overlap of 200. So some of the same information can be in different chunks. Then with the information on how to chunk our information, we call the split documents method and pass in our PDF. And this pages split variable now holds our chunked PDF. So basically all that we're doing is we're loading the pages into a variable. We set up this text splitter saying, hey, when we want to use you, make sure to chunk our work into 1,000 size chunks with a 200 chunk overlap. And then we actually use the text splitter by calling the split documents method, passing in our PDF as the parameters. And now we are done with the chunking process as we have this pages split variable. Next up, we're setting up the directory where we're going to hold our vectorized information. You can store that in your environmental variables, or if it isn't there, it's just going to make a chroma store in this root directory that we have here. And this OS make directory will actually make that directory for us. Here's where we actually set up the vector store. So we use this chroma that we imported, and then we call the from documents method. The documents that we're going to have vectorized are these pages split that we just did above here. We initialize how we want the embeddings at the very top here, our persist directory, and the name of our collection, which is going to be company info. Then we actually have to set up the retriever, which is going to be the variable that we use to actually get information. So in order to do that, we use the as retriever method. The search type will be similarity, and then the keyword arguments we're going to use is twos. So it'll pull up two relevant pieces of information every time we ask it a question. And then here are our two different tool calls. So as I said, we have one to search company information, and we have one to record our answer. So the first one is the company info tool, and we're going to be using this for basic RAG. So we set up our retriever right here, and this is the variable we're going to use for search. And so when we run the invoke method on it and pass in the query, so let's say, hey, tell me a fun fact about San Francisco. That would be the query, which we then call invoke on. And all of our answers would be stored in docs. Now, if nothing is stored in docs, then we can just return no relevant information has been found. But if not, we go through all of the docs one by one, and we extract the page content by the page_content variable, and we put that into a new content variable. Then we set up this formatted info variable, and we append that to this empty results array. So for the first part of the information, we're going to say info, and we're passing in the info number. So on the first iteration, it would be info1 with the content that we just received. Then, like I said, we append that to results, and at the end, we're going to have this array full of information on our query to return back to the LLM. Then the second tool is this record answer tool function. So our agent is going to ask us, tell us a little bit about yourself. And once we give an answer to that, it's going to make or add to an interviewed_answers.txt file. This A right here just means append to what we already have. And we are writing in using the operating system our answer that we passed into this function. So it'll say answer, colon, and whatever we have said. Then it just formats it like this by putting a bunch of hyphens. And it lets us know we have recorded our answer with a preview of what we said. Now, with these two tools, the way we make our LLM aware of these tools is we put the names of these tool functions in a tools array, and we call the bind tools function, passing in these tools we just initialized up here, and setting that equal to our initial LLM. Cool, so now we have initialized our tools and our LLM is aware of these tools. It's time to set up the actual state variable. Here, we're defining the shape of the graph state. So the state basically holds a list of messages, whether that's system, human, AI, or tool messages, and then the add messages bit tells LangGraph how to accumulate these messages as the graph runs. So it's basically the memory for whichever turn we're taking. Next is the little router function. So this grabs the last AI message and checks, did the model ask for any tool calls? If yes, return tool executor, but if no, just return end. This is the branching logic you saw in the diagram. So the LLM either ends the turn or goes to the tool node. Now, this is the main LLM node, and if I didn't mention, basically all nodes are just functions, but this builds a system prompt that tells the interviewer what to do. So it outlines the 4 interview questions in order, and it includes the routing rules. So if the candidate asks about the company, use the company info tool first. If the candidate gives an answer to an interview question, use the record answer tool to save it, then acknowledge and continue. And we prepend that system message to the existing conversation call, llm.invoke, and return the AI's message as the output of this node. Now we have the actual tool executor node itself. This reads the tool calls from the last AI message. For each tool call, it looks at the tool name and arguments, runs the correct tools.invoke, and then wraps the result in a tool message. The important part is that we return those tool message objects so they become part of the message history. The LLM will see those results on the next turn. Okay, so now it's time to wire the graph. We do that by initializing an instance of the state graph by passing in an object's interview state to the state graph wrapper. And we added 2 nodes, right? So LLM points to the call LLM function, and then tool executor points to the tool executor function. The entry point is the LLM node because that's the first node we're going to hit after start. So the way that set entry point works is by default, we have a start node, and the next node from start is whatever we pass in here. So that creates the loop. Then we have the conditional edges. So this just means that after the LLM node runs, we run the function decide next action, where to go next. And if you can remember, if it returns tool executor, we need to go to that tool executor node. But if we don't need to call a tool, we can just go straight to the end. Finally, once tools run, we point back to the LLM, and this is what creates the loop. So LLM, then maybe we need to run a tool, and then back to the LLM. And when no tools are needed, we end the turn. The last line, graph.compile, freezes the wiring and returns an executable graph object we can call from our LiveKit agent. So let me summarize the whole flow. We pass messages into the LLM. The LLM decides if it needs a tool. We run the tool if needed and feed the results back. And we loop until there's nothing else to do for that turn. Once again, that's 2 tools, one to record answers and one to retrieve company facts from a local PDF using Chroma. Except for instead of using the cloud, we're just using a local database and it'll be stored in our local directory. Again, credit where it's due, the overall pattern for tool routing and graph wiring was adapted from the excellent free CodeCamp LangGraph tutorial on YouTube. Link is in the description. I customized it for interview flows, added the answer recording tool, and simplified the RAG output so beginners can follow along easily. Okay, now let's import this into our agent.py file. The first thing is we have to add a LangChain import up at the top here. So go ahead and save that alongside our other LiveKit plugins. And we also have to import that create workflow function from the graph file. So we can just write here from graph, import create workflow. Next, let's edit the instructions a little bit. So instead of just you are a helpful voice AI assistant, let's delete that. And I'm going to paste in this. Once again, you can just get this straight from my GitHub. You are a professional interviewer conducting a job interview. The LangGraph workflow will drive the conversation flow, be conversational, professional, and helpful throughout the entire interview process. All right, so next in this entry point file from the docs, as you can remember, instead of having this OpenAI.llm, we're going to be using that LLM adapter method. So up at the top here, just to make things easier, I'm going to write LG_LLM and set that equal to LangChain.LLM adapter. And inside of these parentheses, we're going to write graph is equal to create workflow. And then down here where we have the LLM, we can just go ahead and delete this and just write an LG_LLM. So that way we are compiling the LangGraph app and we are wrapping it as an LLM for LiveKit via the LangChain plugin. This is because the LLM adapter knows how to drive LangGraph workflows as an LLM stream. As you can see, we just configured the rest of the pipeline normally. That's the only thing we are changing. So let's go ahead and test this out. And one import I forgot is the PyPDF. That's how we're going to be able to load our PDF into a variable. So run uv add PyPDF really quickly, and then we're good to go. Okay, so I'll clear this. And then if you can remember, the command to run is uv run agent.py console. And when I click enter, we should be able to speak to our voice agent. It'll interview us based on the questions that we put in graph.py. So however, if you scroll down here, we put in all the questions right here. We said, tell me about yourself, tell me about your technical background. Now tell me a time when you faced a significant challenge. It should ask those questions chronologically in a row. And if our code works, it should record our answers in a new text file. We'll click enter.
Hello, thank you for joining us today. Let's start with the basics. Could you tell me about yourself? Please share your background, what you're passionate about, and what brings you here today.
My name is James Bradford. I'm passionate about computer science and I have a background in software engineering. And I'm interested because the job title interests me.
That's great to hear, James. Now I'd love to learn about your technical background. Could you tell me about your experience with technology? What technologies, programming languages, or technical projects have you worked with?
Yeah, one that comes to mind is a sales CRM that I built using a Django server. I built it in Python, and I stored the backend database using PostgreSQL.
Excellent. Now, I'd like to hear about a time when you faced a significant challenge, either technical or professional. Could you walk me through the situation, what obstacles you encountered, and how you overcame them? What did you learn from that experience?
Yeah, so one that comes to mind is in my previous internship when I made a pull request, or I guess push request, my code, I did not validate it beforehand, so it did not pass any of the continuous integration checks. But once I meet with my team and they told me what I did wrong, I made sure to always validate my code and made sure it agreed with what we already had deployed.
Thank you for sharing that with me, James. Now I'd like to give you the opportunity to ask me anything about our company, the role, or anything else you'd like to know. What questions do you have for me?
What was your guys' revenue in 2024?
In 2024, our company's revenue was $8.4 billion, reflecting a 20% year over year growth. If you have any other questions or need more information, feel free to ask.
Yeah, can you tell me about your guys' recent achievements?
Recently, our company has achieved several milestones. We launched Tech AI 3.0, an advanced generative AI model designed for enterprise use. We expanded our data centers in Singapore and Frankfurt to better serve our global clients. We were recognized as a leader in the 2024 Gartner Magic Quadrant for Cloud AI platforms. If you have any more questions or need further details, feel free to ask.
Got it. Thank you for interviewing me.
You're welcome, James. Thank you for taking the time to speak with us today. If you have any more questions or need further information, feel free to reach out.
Okay, and as you can see, it popped up this new interview_answer.txt file where it recorded all of our answers that I said. And the RAG was working. We can look down here below. We see it ran the company info tool when I was asking about the revenue and recent achievements. And it was actually accurate from what I gave it in the PDF. We can see real time how the conditional branching worked. I asked a question at the end there where it didn't need to call a tool and it responded to us right away. But if it did need to call a tool, it told us what tool it was calling and it lined up with what it needed to do. Porting this answer tool right here and it says my answer, or calling the company info tool. So now that that's done, let's just add a face to our voice AI agent to make it even more realistic. That'll be the last step in setting up this interview agent. Go to the terminal here. So head over to the LabKit docs and click on AI agents and scroll down to where it says integration guides. And we're going to be integrating a virtual avatar. And for that, we're going to be using Hedja. All we have to do is install the plugins, get our API key and our .env file, and start an avatar session with the ID of the avatar we want. I'll walk you through all of that. So I'll copy this command. All right, so let's paste in that command, but remember we're using UV. So instead of pip install, let's delete this and write UV add and click enter. And I'll copy this. Now it's clear and paste in the second one, but then again, we have to use UV add. So then we delete this and run UV add. Okay, let's go get our API key and I'm gonna log in. And go down to the bottom left and click on API, and our API key will be right here. I'm just going to copy that. Now, if I head back to the code, all right, so instead of that .env.local file, now we can just write in here, hedge_API _key, and paste that key in. All right. Now head over to the agent.py file, and we need to add the plugin. So after Solera, just write Hedra, save that. And we're going to be using an image from our computer. So right from PIL, import image like so, and then scroll down to below where we initialize the session. Because here we need to write avatar_image is equal to open. And instead of avatar.png, we're going to get it from the present working directory of the photo on our computer. So I'll just paste that in right here, and that is the image. And the last thing you have to do is just initialize this avatar instance using this avatar image. So let's copy that and just paste that in. So let's go ahead and paste that in right here. All right. Okay. And we have to start the avatar session. So let's go right here and write await avatar.start. And we pass in the session, and room is equal to ctx dot room. And okay, now we're ready to test speaking with our avatar. So what should happen is we'll go to the LabKit playground and talk with our AI avatar, and we'll have our answers updated in this interviews.txt, and we should be able to perform the RAG with the Chroma database that we set up locally. So the command to do this it's similar to the one we just ran, the UV run agent.py. And instead of console, just run dev. do live kit playground, and then click on this first link right here and connect to our project. So for me, that's LK Cloud Project. And once I click connect, since we're already connected in the terminal, we should be able to speak to our agent. Click connect.
Hello, thank you for joining us today. Let's start with the basics. Could you tell me about yourself? Please share your background, what you're passionate about, and what brings you here today.
Yeah, so my name is James. I have a background in software engineering and I have interest in cloud computing and building AI solutions. And honestly, what had me interested was the salary.
That's great to hear, James. Now, I'd love to learn about your technical background. Could you tell me about your experience with technology? What technologies, programming languages, or technical projects have you worked with?
Yeah, one that comes to mind is a sales CRM that I built using Django. I wrote it in Python, and I also used PostgreSQL on the background, in the back end to store some information about the users. So yeah.
Excellent. Now, I'd like to hear about a time when you faced a significant challenge, either technical or professional. Could you walk me through the situation, what obstacles you encountered, and how you overcame them? What did you learn from that experience?
Yeah, one time when I was coding in my previous internship and I made a pull request, I forgot to check for the continuous integration checks. So I did not validate my code and it didn't agree with what we had deployed. So I had to fix that by meeting with the lead engineer. But after that, I did not make the same mistake twice.
Thank you for sharing that with me, James. Now, I'd like to give you the opportunity to ask me anything about our company, the role, or anything else you'd like to know. What questions do you have for me?
Yeah, can you tell me about your guys' mission statement?
Our mission at Tech Company Inc. is to empower businesses through intelligent automation and data driven decision making. We envision a world where every organization can seamlessly integrate AI into their operations to improve efficiency and unlock growth. If you have any more questions or need further clarification, feel free to ask.
Yeah, can you tell me about some of your guys' key clients?
Our key clients include some Fortune 500 companies across various industries such as finance, healthcare, retail, and manufacturing. Notable partners include Megabank, HealthPlus, RetailMart, and Automotive X. If you have any more questions or need further details, feel free to ask.
Got it. I think that's it for now, and I'm looking forward to hear back from you guys.
Thank you, James. It was great speaking with you today. We'll be in touch soon regarding the next steps. Have a wonderful day.
We can stop this terminal. So let's clear that out. And after we stop the terminal, we see that we have our answers in interview answers.txt. So it asks us 3 questions, and I answered 3 questions. And it said, we have a background in software engineering, blah, blah, blah. And then it also got my other answers as well. And we see that when I pulled up the PDF, it was saying the correct answers. So that is it. And good job if you got this far. So that's it, guys. Thank you for sticking around for the full tutorial. If you need any help, just let me know in the comments, and I'll see you in the next one.